Hey guys, and welcome back to this class, Deep Learning Prerequisites, Logistic Regression in Python. In this lecture, we're going to talk about the cross-entropy error function. Don't worry about the name, the concept is actually very simple. Recall that in my linear regression class, we use the squared error objective function, and that's a fine error function for regression, because it assumes your error is Gaussian distributed. Of course, the logistic error can't be Gaussian distributed because the output is between 0 and 1, and the targets are only 0 or 1. So that's why we need a different error function. What do we want out of an error function? Basically, we want it to be 0 when there's no error, and we want it to get larger the more incorrect we are. Let's look at the cross-entropy error function and see how it accomplishes that. Alright, so the cross-entropy error function is the negative of the target times the log of y plus 1 minus t times the log of 1 minus y. First, let's observe that only one of these terms will matter at a time. Why is that? Because either the target is 1 or it's 0. So if the target is 1, only the first term matters, and if the target is 0, only the second term matters. Next, recognize that y is a number between 0 and 1. It's the output of the logistic. So if we log a number between 0 and 1, we'll get a number between 0 and minus infinity. Notice how we take the negative of the whole thing. So if we get negative infinity, that will turn into positive infinity. Alright, so let's try some examples. Let's say the target is 1 and y is 1. Then we get 1 times 0, which is 0. So if we're correct, the error is 0. That's great. Notice that if the target is 0 and y is 0, we get the same thing. Let's say the target is 1 and y is 0.9, so we're mostly correct. That gives us 0.11, which is a very small error, so that's also great. Now let's say the target is 1 and y is 0.5, so we're right on the cusp of being correct. That gives us 0.69, which is a bigger error, so it seems to be working so far. Now let's say the target is 1 and y is 0.1, so we're very wrong. That gives us 0.23, which is an even bigger error. So that's great. Cross-entropy is working as expected. Finally, note that we want to calculate the total error to optimize over all the training data simultaneously. So to do that, we'll sum up over all the individual errors. That gives us the sum over all n, the individual cross-entropy we saw earlier.